Okay. Drawing or constructing a ruler and a protractor, and construction requires a compass. Okay. So for number 1, we're supposed to draw a median, and a median is perpendicular to line LU, correct?
Yeah.
Okay. So let's see. The way we can do this, actually, do you have, well, no, I'll make an attempt to show you how to do this. I might be able to just describe it.
Okay.
Take your compass and put the needle point right there.
Okay.
And draw an arc that intersects line LU in 2 places.
Okay.
You with me?
Yeah. Yeah.
In other words, here I can kind of draw it as I talk about it, just so you won't have any. Okay, so that's where you put your compass.
Okay.
And it has to intersect before you get to U. In other words, you're going to draw an arc like that.
Okay.
Okay?
Yeah. Yeah.
You can't draw an arc that intersects beyond U. I mean, I guess you could. You actually could. You could extend LU. In other words, you could use a straight edge and draw it forward like that, and then you could draw it anywhere you wanted. But the easiest way is if you can draw an arc that intersects it in 2 places.
Okay.
Now, without changing your compass, put 1 needle point there and draw an arc up there like that.
All right.
Put the other needle point at the other intersection.
Okay.
Without changing this distance, draw another arc like that.
Okay.
Now, when you connect the 2 lines, you will have a perpendicular line.
Okay. Do I have to do the little, 90 degrees mark or anything?
Well, that's what, in other words, that means it's 90 degrees. But in terms of this problem, probably not. In other words, when you do it on here, you're going to see this arc, you're going to see this arc, you're going to see that arc, and you're going to see that arc. And then once you connect them, it will be clear to your teacher that you did it correctly, drawing a median. Now, let's go to the next one. Construct a median LT. All right. First of all, gotta look something up because I don't want to be telling you wrong stuff. Points of concurrency. Have you talked about points of concurrency?
No, not very much.
All right. I'm glad I looked this up because I was giving you the wrong problem. A median bisects the opposite side. It's not perpendicular to it. You know what I mean? In other words,
Yeah.
I did this wrong. I drew a line from S to there that was perpendicular. That's not what I want. I had to refresh my definitions. Okay, a median goes from S to the midpoint of the other side, hence the word median, such that that side is equal to that side. So in this first problem, let's go back, and we're constructing SM. So the only thing we have to worry about is where is M? In other words, how do we bisect LU?
You just take the compass and make it wider than the midpoint, right? On both sides.
Well, that's a good point. It's been a long time since I've had to use a compass. It's not something that I'm actually really... Let's see, what can we do? Basically, a compass is a measuring device. There you go.
Okay.
You got it right. Okay. Here's the way you would do it. You would put the... Let's eliminate the median first of all. We're trying to find the point M that is halfway between L and U. Well, if we put the needle there and make sure that the distance to the pencil is more than halfway and draw an arc, we'll get an arc like that. You with me?
Yeah.
Leave the measuring the same distance, don't change it, and draw another arc.
Okay.
Connect the two intersection points and you will have bisected that line. In fact, you will have bisected it with a perpendicular line even. So this happens to be perpendicular, but we're not caring about that. We're trying to find where the median point is.
Okay.
And we found it. Okay, so now to create SM, we just connect M to S. And we have drawn the median.
Okay.
Okay. Let's go to number 2. Boy, I'm glad I looked this up, because otherwise I was going to give you completely wrong information. All right, in this one we've got L, S, U, and they want a median LT. So the only line that could be LT is that one right there. In other words, and what needs to be true about UT and DS?
They're... Well, T's the midpoint of both of them.
Okay,
But,
so that has to be equal to that.
Yeah.
Let's make that a circle rather than a hash mark. So again, the problem merely becomes bisecting US. Again, put the needle there. Make sure that your compass is more than halfway and draw an arc. Then put the needle at U without changing the compass. Draw another arc that intersects the first arc in 2 spots, and then connect those 2 lines. And those 2 lines will bisect that US. It seems like a compass is a device for drawing arcs. It really is not. It's a measuring device. That's all. It measures linear length. It just happens to be that if you draw an arc from S the distance from there to there is the same as the distance from there to there is the same as the distance from there to there. In other words, is all you're drawing is a bunch of points that are the same distance from S. And that's useful to keep in mind. All right. All right, an angle bisector. Let's first of all figure out how we would bisect an angle using a compass. In this case, you set the needle mark at A, set a distance that's equal to AB, and draw arcs through both of them so that you're guaranteed to have AB be the same as AC. So now this is the same length as that.
Okay.
Now go to point C and set a distance that's greater than half the angle. In other words, a distance that's going to create an arc kind of like that. Remember, my needle is on C, so I'm drawing half of a little circle. Without changing your distance, go to B, put the needle on it, and draw the same arc.
Okay.
Draw a straight line between those 2 points and A, and you will have bisected A. In other words, this angle will be the same as that angle.
Okay, cool.
Okay, so let's figure out how to do it on 3. Sometimes these can be a little tricky if it's an obtuse angle. See, that's C, that's U, that's B. They want to draw angle bisector CT. Well, that means T has to be somewhere there, but it's not halfway between U and B. What has to be true is that angle has to equal that angle. Okay?
Okay.
So let's use the same strategy as we used previously. Where do we start? In other words, let's get rid of this bisector since we don't know where it's at. Pi, come here. Pi. What's going on? What's all the barking going on? Okay. So do you remember how we bisected the angle before? Where'd we start? In other words, before we had this angle right here and we were trying to bisect it, we started right there. We started at the vertex of the angle we're trying to bisect. And we just measured off 2 identical distances. Mark, you still there? Mark, are you back?
Hey, David. Yeah.
I apparently lost the audio. Were you able to hear me, or did you hear nothing that I said?
I didn't. No. It said I lost connection for a second.
Okay. Yeah, I heard a pop when you came back in, and I finally figured out that you weren't hearing what I was saying. Let's see. Okay. Well, how do we bisect angle C? Using a compass.
By putting those 2 little hash marks on the side.
Okay, where do we put the needle?
We're bisecting C, right?
Huh?
We're bisecting C?
Correct.
Okay, so we put the needle on C then.
Okay, and then we make some distance that's less than CU for our compass.
Yeah.
And we make a hash mark there and another hash mark there. And now we know that side's equal to that side, right? Remember, a compass is a measuring device. Now what? Let's call this Y and Z. Now
And then we take the needle and put it on like Y or Z, and then we put another arc down.
And this time the arc really can be anything we want. I could make a big arc if I wanted. Notice what happens if I make a nice big arc. Okay. And now I go to Z, and I make the same size arc. Well, the same size arc is something like that. You still, wherever those two things intersect, connect it to C, and you've got an angle bisector. Okay?
Okay.
We wouldn't do it that way. In other words, the way I would do it, I would want to be more specific. So I would put the needle on Y, and I would set the arc to be approximately like that, in that ballpark.
Okay.
Distance-wise. And then, without changing the distance, and this is key, you can't change the distance on the compass, you set the needle on Z, and you draw a similar quarter circle. Now, connect that. That should be a straight line to there, and you have an angle bisector where that angle is equal to that angle.
Okay.
Okay?
Yeah.
All right. Yeah, compass is one of the few things that it's actually hard to do online. Just because, I can't physically demonstrate it. This time they want to bisect U.
Okay.
Okay. So what do I do? Work me through the process step by step.
We use an arc to make two equal sides.
Okay, by working me through the process, tell me where I put the needle and where I put the arc marks.
We put the needle on U and make an arc through lines C and D.
The distance that I'm going to make, is it going to be less than CU or greater than CU?
Less.
Okay, so let's make an arc right there and the same distance over here. And the key is this distance right here is the same as that, guaranteed by the fact we made it with a compass. And we'll call that Y again and Z again. Now what?
And then you use it to make two separate arcs
Put the needle where?
On Y.
Okay.
And then you make an arc kind of in the middle. And then the same thing for Z.
Yeah, you kind of want the arc to do something like that. In other words, you want it to be a side.
Yeah.
First of all, it's got to be at least big. Notice the problem if I make too small of an arc. If I make an arc like this and then do the same thing with that, they don't intersect. So I've got to make an arc that's big enough that it's going to intersect the arc from Z.
Okay.
Because it's their intersection point that we draw the straight line between. So I've got to go at least out to there distance-wise and draw an arc. I'm going to draw it kind of like this. Okay. And then what's next?
You do the same thing from point Z.
Okay, put the needle there without changing the distance. Draw an equivalence arc. In other words, it'll always come out circular. And connect all 3 points. And if they don't line up in a straight line, you've done something wrong. In other words, the way I just did it, you'll notice that they weren't quite in a straight line. If I connect that to that, it doesn't make a straight line to you. But that's because I'm just freehanding it. I'm not doing it with a compass. This line that connects this point with this point and will connect with you will bisect you. This angle is equal to that angle.
Okay.
Okay. Both of those are fairly straightforward. Let's see what they got for 5. Draw an altitude. Okay, I think I can figure out how to do this, even if I don't remember. What's amazing is how many geometry students I have and how rarely I have to do this. Let's see, what's that letter right there? Slightly out of my picture for 5. The lower left.
Let me look.
It's probably C. We'll call it C. It doesn't matter whether it's C or not.
Yeah.
Okay? We're not even going to use it. The goal here is to construct a perpendicular line. That's what an altitude is. It measures the perpendicular distance to the line. Okay? Well, if we put the needle on you and make the distance to the pencil exactly SU, then I'm going to construct an arc that looks like this.
Okay.
It's not going to work, is it? I guess we have to make the arc bigger than SU and construct an arc that looks something like this with the needle on U. That's not going to work either. All right, let's go back. Let's put the needle on S, since that's where we're drawing the altitude from.
Okay.
And I can make the distance to the compass be U. Okay? So my arc is going to intersect right there and right there.
Okay.
Now, to construct a perpendicular, I know that if I can bisect this line segment, I've got a perpendicular. Okay, so now I'm going to put the needle on point A, and I'm going to draw an arc like this. And then I'm going to put, without changing the distance, I'm going to put the needle on U, and I'm going to draw an arc like that. And those 3, that point, and that point should be in a perfect line. And we know 2 things, that we are going to bisect, in other words, AZ is equal to ZU. But more importantly, when we do bisect that line segment, we are guaranteed to have a perpendicular line right there. So the goal to draw an altitude is to really break up the line segment CU into some line segment that I can work with. And the way I did it actually works perfect. If you make the distance of your compass go from S to U, you wouldn't really want it to be bigger than that, because then the arc would be out there and you'd have no clear point to put your line unless you extended CU some. So making it exactly SU distance works perfect, because now I'll know that ZU is equal to ZA, and just drawing a line between that point and that point gives me Z, and it's guaranteed to be an altitude. All right, let's see. We got one more here. And this time we want to calculate an altitude from U.
What was that?
Number 6. Notice that the altitude from U is going to look something like that. It's going to be outside the triangle. I cannot draw a line from U to the line SC and make it perpendicular. Anywhere I draw it is going to create an obtuse and an acute angle. So the only way I can construct it is to extend CS out with a dotted line, and then try to figure out how to draw an altitude to that extended line. Well, I'm going to do it exactly the same way I did it before. In other words, I'm going to put the needle on the point that I'm drawing the altitude from, I'm going to make the distance greater than SU, such that I make an arc that goes like that and like that. Okay, you with me?
No, the call just cut out.
My needle is on a U, and I'm drawing an arc that is a distance greater than SU. And that arc is going to look something like this. Okay, and the only points if I drew the whole arc, it would look something like that. But the only points I really care about are the points where it crosses SU. Because I want to make sure that this distance is the same distance away from U as that distance is. Okay?
Yeah.
Now, my goal is to bisect YZ. So we've turned the problem into an altitude into a line bisector. I don't really care about this altitude yet anymore. What I care is, how do I break up YZ into 2 equal segments? Well, I put the needle on Y. I draw an arc like that. I put the needle on Z without changing the distance. I draw an arc like that. Connect the 2 intersection points with a straight line. And that point is the midpoint between Y and Z. And it's also an altitude, because by your geometry theorem, when you bisect, when those two are equal, that is an altitude. It's a perpendicular bisector is what it is. What we drew was a perpendicular bisector.
Okay.
You can get the instructions on how to do that on chapter 5.1, page 264 in my book. It shows you exactly how to draw a perpendicular line through a point, and it automatically will bisect that line segment.
Okay.
Okay? All right,
Yeah.
Mark. Let's see. Do we want to leave the schedule like we've got it?
I think that's good.
Okay. Next week, that means Tuesday at 4:30, Thursday at 4. Just
Sounds good to me.
try to give me as much notice as you can if you need to cancel. Okay?
Okay, cool.
All right, Mark. Have a good one. Talk to you next Tuesday.
Thank you.